Okay, in this video, we will be doing this differentiation question as I have mentioned in the previous video. This is like a bit more tougher than the previous question, but I'll be showing you how to do this with some certs and indices knowledge. Okay, but I would say it's a mix of both certs and indices because you can look at this in this form here. It is like a bit in cert form. Okay, so yeah, I'll get started on by showing the cert rule first, and then after that we'll go into the question. So in certs or in indices, you have seen this before, square root a over b, the whole thing, or you have seen this one in green, square root a, hold on, square root a b, okay, like that. Okay, hold on, yeah. So what do we know about these rules? Okay, so we know that square root a over square root b, it can be expressed as square root a, square root a over square root b. Okay, so you can express it like, or you can express it like what I'm gonna write in white, a over b power half. Okay, and you might have seen this rule in indices, a over bc, which is a, okay, wait, hold on, I'll write in a different color, a power b c. Okay, this equals to a c over bc. Okay, so the c, take note, is at the power. Okay, so this is how I'm gonna leave it, and we might have thought of the times also in green here. So what do we know? We know that square root ab is the same as square root a square root b. This is what you might have seen in indices or in certs, yeah, or you can leave it in this way, which I'll write it in white as well, ab power half, and we know this rule, abc c is the same as acbc. So this is how the rule is derived via in indices form, which is in white and red, versus in cert form, which is in blue and yellow. Okay, so you see the white one is here, this is in indices, and this is a indices rule. The red one here is the indices rule. The white one is also an indices rule, but it's a way of how we express these kinds of terms, yeah. So without further ado, let's move on into the question. Differentiate the following with respect to x. Y equals to square root the whole thing, 2x plus 2 to the power of 4 over 6x plus 7. Okay, so what we are going to do is we will make sure that it is in a very nice form to differentiate. And from this rule here, what do you think I can do first? Do you think I can break them up? Can, right? Because of this rule here in yellow, square root a over b, the whole thing, is the same as square root a at the numerator and square root b at the denominator. Or we can write it as a over b to the power of half. Okay? So maybe for like you to understand, I'll write it in square root form. So we know that y equals to square root 2x plus 2 to the power of 4 over square root 6x plus 7. Okay, so this is what we know so far, yeah. Okay, and what else can we write? Okay, I plan to leave my answer in positive indices form because I don't want to see square root, so it will be easier for me to differentiate. So I will write another line, y equals to 2x, 2x plus 2 power 4 whole thing power half over 6x plus 7 power half. Okay, you might wonder, why did I write a square bracket here? Is because I have already a round bracket here, which is a power 4, and I don't want to confuse myself. So I put a square bracket, so I will not get mixed up. Okay, so now if you notice, remember this indices rule here where we say yeah, this one. Let's just say never mind. I'll write it A B the whole thing C. Okay, so this will be equal to A B C, or we can say write it in another way, A B times C. So when this one go here is a times. Okay, so what am I going to do here? Okay, you might wonder. I am going to expand the 4 in here and I will times it to make it a simplified version, or like make it easier to solve the question. So y will be equal to 2x plus 4, 2x plus 2 the whole thing squared, because 4 times half is the same as 4 divided by 2, which is 2, and then over 6x plus 7 to the power half. Okay, so now we are going to start differentiating. Can we differentiate in the first place? Can or cannot? Can, right? It's already in a very nice form, right? So I'll differentiate in red, yeah? dy over dx, copy bottom, differentiate top, right? So 6x plus 7 to the power of half. Now I will differentiate my top. So when I differentiate my top, right, I get so what kind of differentiation is this? This is a chain differentiation. Okay, so what do? We will do chain differentiation. Power number bring down, power number minus 1, and we differentiate the inside bracket. So power number bring down, it will be a 2 bracket 2x plus 2. You can write the power 1 here, but for me I won't write because it's a bit redundant. But you can write, no problem. In the exams or your WAs, you will not be penalized for that. Okay, so but in this case I will not write because it's still the same. 2x plus 2 to the power of 1 is the same as 2x to the power 2x plus 2. Okay, and then we add a minus sign. So we have done the first step. Now second step, we will add a minus sign, and then we will now copy the top and we differentiate the bottom. Okay, so when we copy the top, it will be a 2x plus 2 squared, and then now differentiate the bottom. Ask yourself, the bottom, what kind of differentiation is this? It is still a chain differentiation. Okay, so if we know that it's a chain differentiation, same thing, power bring down, power number bring down, power number minus 1, and we differentiate the inside bracket. Oops. Okay, so what will we do is we will bring our power number down. So it will be a half bracket 6x plus 7. Okay, wait, I forgot to do something. I forgot to differentiate the inside bracket. Okay, give me a moment, yeah, I will get it fixed right here. So when we differentiate the inside bracket, I will get 2. Y constant, remember, ignore. Okay, because when we differentiate the inside bracket, it is a basic differentiation. And usually for chain rule, you will usually get a basic differentiation for the inside bracket. Okay, but in this case, I will just write it down, yeah. So we know that it's minus 2x plus 2 squared because we copy the top and now we differentiate the bottom. Is a chain differentiation. Okay, so we know that this 6x plus 7, half minus 1 will be minus half. Okay, and then we know that we have to differentiate the inside bracket. So what do we know? We know that this again is another basic differentiation. So we will just get 6, isn't it? Okay, and I want to make my life simpler. So I will simplify the half and the, I will simplify, hold on, let me use another color. I will simplify the half and the 6, and the 6 will become a 3. Okay, or I can just write it like that, cancel, and then write back in orange. It's a, am I right, in purple, because it's a new value already, 3, because half times 6 is the same as 6 divided by 2, which is 3. And then we will now draw the long line. And it's over 6x plus 7 power half whole thing squared. In this case, I will still use the one here, ABC, which is ABC, okay? Or AB times C. And the BC is at the power number. So, I will just write 6x plus 7 to the, yeah, that's it. Because y half times 2, okay? Half times 2 is the same as 2 over 2, which is just 1. So I can actually write a power 1 here. But like what I said earlier, I find it a bit redundant. Because I think that it's still the same thing, isn't it? So why do I need to write the 1? But you can write it. You will not be penalized. Okay? So let me just get this erased quickly. And yeah, I'll just erase the 1 because I think it's a bit redundant. But you can write it if you want. Okay? So now we are going to start to factorize or simplify. Okay, so if we look at these two terms here, what we are going to do is we are going to start to simplify once again. Yeah, so let's look at our numbers first. So between 2 times 2, which is 4. So between 4 and 3, is there anything common? No, right? So let's look at 2x plus 2. Okay, 2x plus 2 here and 2x plus 2 square. Okay, which one is in common? 2x plus 2 or 2x plus 2 square? Remember, when I say when we factorize, always take the lowest number. So I will take 2x plus 2. Okay, so now this is the part. 6x plus 7 to the power of half and 6x plus 7 to the power of negative half. What will I take? Okay, remember, always take the lowest one. So indeed, I will take 6x plus 7 to the power of minus half. Okay, but I realized something. I will highlight this for you so you will know what I'm talking about. The basic differentiation. Which one is the basic? Which one is the chain? Whatever, you know. Okay, so now are we done? Yes. So let's put our square brackets. So what we'll do now is we will start to add the stuff we are short of. So for the first term, 6x plus 7 to the power of negative half. Let's do that first. So you see, we have a half here and a negative half here. So we need one more set. Remember, ABC, which is the same as ABC. The one here. Okay? The one that is with the laser, So we know that this is it's an indices. So times will be plus. So okay, let me emphasize again. So it'll be a 6x plus 7, one set. Because AB times AC, which is indices AB plus B plus C, right? And negative half plus 1 is just half. Okay? So, I will also note where the 1 here, I find it a bit redundant. But you can write lah. Okay? So, what are we left off now? How about the 2x plus 2? We have already, right? No need already, right? So, it will be left with a 4. 2 times 2 is a 4, right? And now we add the minus sign. Okay? So, when we add the minus sign, let me think. So, now let's start to factorize again. So, 2x plus 2 and 2x plus 2 squared. We are short of 2x plus 2, correct? So, I'll write in another color, Just write in red. 2x plus 2. And then, what are we short of here? We are short of hold on, let's look at the 6x plus 7 to the power of minus half first. So we look at this and this. They are the same, right? No need. Okay? So now we are left with the 3. So we will add the 3 inside and we will close the bracket. And this is over 6x plus 7. So now we will simplify the inside bracket, which we will get 2x plus 2, 6x plus 7 minus half bracket 24x plus 28, yeah? So it'll be a 24x plus 28 minus 6x plus minus 6. Sorry, close. But actually from here, never mind. I will still write in square bracket because I have a lot of round bracket here, as you can see, right? So it'll be over 6x plus 7. Yeah, that's it. 6x plus 7. Okay. So now we can cancel the half and the 1. So this will be a power 1. I was about to say that. So this will be, when you bring minus half, so 1 minus half should be 3 over 2, if I'm not wrong. Okay. Let me think. Hold on. So 6 plus 7, negative half, and 1. Yeah, 3 over 2. Okay. So because why? 1 plus half is 1.5, which is 3 over 2. And in A math, you can write improper fractions. So it's okay. This will be equal to 2x plus 2. And this one actually gone. Okay. So yeah. And then we can now write in round brackets. We simplify the square bracket. We will get 18x plus 22. And this will be over 6x plus 7 to the power of 3 over 2. Or you can leave my answer, which I'll write it out in pink. Okay, or I can write like that, or never mind, I will use blue then. Or you can write like that. Well, honestly, you might be wondering, okay, I'll explain it later. Let me write out the answer first. Or you can write it like this, over square root 6x plus 7 cubed. Doesn't matter. For me, I leave my answer in red, good enough already. Okay, I will not want to bother changing it to square root or what. Okay, that's it. I just want it to be in positive index. No negatives, no whatsoever. Okay, so you might be wondering, do I expand the brackets like that, like that, like that, like that? Do I or do I not? Okay, so I would say I will not do it, but you can do it. But just don't make careless mistakes. And for me, I leave my answer like this, good enough already. Okay, so yeah, I will send a screenshot of this and also the different rules. So if you want to have a look, go ahead. Yeah, but looks like it's very, very small. Take a screenshot. So yeah, I'll just put it like this. Okay. If not, I can make it bigger. I'll adjust it here and there and I'll take a screenshot of it. Yeah. Alright. So see y'all.